Good morning, all. Today, I'm going to talk about the Apache Kafka. Everyone knows about that Kafka has been used in the data science or maybe like in the data related activities like that. So, but how we are going to use those things for the network engineers, we will be trying for that today. I've been going through this a lot of documents over there in the internet for how to use the Kafka for network engineering solutions means it's been used in all the IT industry everywhere where the data streams are happening and people are subscribing to the topics and they're receiving the messages like that. It's a continuous streaming messages which are being sent through this Kafka. It has been managing so properly. And there are many other solutions which are already been there in the market, but how the Kafka is getting differentiated from that? Kafka is being used by the software engineers, and why we are going to be get involved in this. Why the network engineers need to know about that Kafka, Apache Kafka, So these are all the questions maybe there in your mind as well as in my mind also, 2 months back. And I seen some of the informations about that Kafka also can be used for network engineering operations as well. Means like we will be pulling up some data informations from the network devices by logging into that. By using the Kafka, we can ask the particular device to produce the streams to that Kafka streams like that. Kafka, like a consumers, we can able to see that what's actually happening on that. And we can see that continuous streaming which has been flowing through that, like the logs are there which has been produced everywhere. Network devices are producing the logs always, So those things we can use it with that Kafka. Kafka, you can say that it is coming under the network automation platform, I can say that. So we have already the Ansible which has been running on. I've been doing a lot of projects on Ansible. And we've been doing something on the Python as well. Then how the third one is, we can call it as like a Kafka has also been in the market, I can say that. Kafka has been used by mostly like the web related activities, and it has been used with Elasticsearch, and the Kibana is a tool that which is used for to maintain all the streams which are coming up on this. And Kafka can be settled. It can be settled. We can set it up in the public clouds also, like AWS cloud, Azure cloud, as well as in the Google cloud also we can make that up. So it's very easy to go for the Kafka, but easy in the sense, but like we just need to learn about the Kafka first of all. What is Kafka? How to configure that? How we are going to tune those things that to talk to the network engineers, network devices, and to produce the outputs for us, and for a continuous streaming of the outputs on this, because we are going to manage minimum at least 5,000 to 6,000 devices on the network. That's a huge network, huge data which has been flowing on every day, every minute, every hour, every day. I can just say that every week. So we are collecting all the logs and we are analyzing them, and we producing the, like finding out the faults and troubleshooting and other things which we are doing there. So in that arena, that Apache Kafka can be, it can be a good choice to go for it, but it requires heavy skill for you. Means you just need to understand that how the Kafka is been working on, how to configure it, how to tune it up, and what all the configuration parameters are required for that. How the Kafka is going to talk to the network devices, first of all. How we making the communication between the Kafka and the network devices and a network. Like how we are configuring the Ansible and the Python and other things all. We'll be creating the host file on where the Kafka is running on that. I installed the Kafka in Ubuntu 18 I installed it, then I upgraded to 20. It's perfectly working on that. You can take the Ubuntu 20 and you can install that Kafka. There are some versions are available, 2 point. Some versions are available on that. We can download that. And most importantly, Apache Kafka is a 100% free. Means it is a open source material. We can have downloaded the latest versions of that, and we can start configuring on this. Lots of documents available on that, but you just need to go through that. You should be having the patience to read all the documents so that you can configure that Apache Kafka. Why I am so much interested in Kafka in the sense, because we are all doing the lot of automation things which is happening on the cloud as well as in the on-premises, and in our data centers also using the Ansible and Python and other things. So that is the third one which is there in the market. That is a Apache Kafka. People are talking about it because the data science people, the web scraping and other people, they are doing that. Like a lot of other things which are happening with the browser related things and all like that. They do this all Kafka. So I thought why shouldn't I try for this Kafka for network engineers as well. There is a book has been released by Eric Cho. Somebody is he released there. I just got a chance to buy that book and I start reading them. It was quite interesting. But beyond the book, we just need to do a lot of things because it has been given in until intermediate level. He has given that. He has just explained everything. But we need to go far away because we just need to implement that in the production environment. Anyway, let us go through these slides one by one. And I'll be starting the slides now. What is Kafka? You might be thinking, don't we already have a lot of data storage systems? Why do we need yet another storage system? You're right. We do have a lot of storage solutions such as relational and non-relational databases, caching systems, big data storage clusters, search solutions, and many more. But in the most of the data storage cases, the data is entered in once, stored in the database, then retrieved later when needed. This is how the conventional databases is going on. Like whatever the network data streams which you are getting on that, logs we are getting that, troubleshooting things which you are doing that. Everything is being stored in once and we'll be doing all these things. But what sets Kafka apart is built from the ground up to treat the data as a continuous flows of information that are constantly being produced, enhanced, manipulated, and consumed like that. So we have a NetFlow. Cisco NetFlow has been there. It's doing the same job, but that is a proprietary thing. You just need to buy it. We have to pay a lot of money for that, and he'll have to configure that and all. So it's like NetFlow. NetFlow we can configure that, but we require to set up a huge systems and other things and all together. But Kafka is completely free. Instead of focusing on holding the architecture itself, Kafka architects itself as a system that allows the data to be continually evolving stream of informations. According to the Apache Kafka project page, Apache Kafka is an open source distributed event streaming platform used by thousands of companies for high performance data pipelines, streaming analytics, data integration, and mission critical applications like. So this I took it from their own page. And the companies which are using the Kafka, Airbnb, Datadog, Etsy, and many other across the different industries using the Kafka to build the data pipeline. It's all related to the data because we are all having the data only. So these are all the companies which are using that. These are all the companies. Sorry, Datadog and Etsy and other things are using on this. And these data pipelines use a variety of services that both produce and consume the data in a continuous format. We are talking about only the continuous things. Continuous in the sense that stream of data is going to be coming up like that, like a video streaming, audio streaming, which has been happening. If somebody is talking, if somebody is like a movie has been turning on. In Netflix, we are seeing a lot of movie. There is nothing but a data streaming which is happening from the multiple servers on that. Right. So this is what we are talking. Next, history of the Kafka. Kafka was originally developed in LinkedIn by J. Krebs, Neha Narkade, and June Rao, the Wikipedia guy. As the story goes, J. Krebs named the project of Kafka because he likes the author Franz Kafka's work. He is from, actually, Franz Kafka is from the Czechoslovakia. He is an author, he is a writer. And a system optimized for writing. So Apache Kafka is also a system optimized for writing. That's what he believes. Right? The project was released as an open source project with the Apache Software Foundation in early 2011 and went from the incubation to the top levels Apache project on October 23, 2012. It's written in Java and Scala with significant community backing. Community backing, without that, open source cannot work at all. No. The three original developers left the LinkedIn and found a company called Confluent. We are still installing a lot of things as a name of the Confluent, like a package we are installing like a Confluent. The company aims at to set data in motion with Kafka as at the center of that idea. As a result, many of the Kafka related projects, documentation projects, products and initiatives are actively developed and sponsored by Confluent. This is just a history of Kafka. I can see it in the Wikipedia itself. Why do we need Kafka? Means like a network engineers, why do we require? Where we are going to use this all in the network, that is what we are much concerned about that. We don't worry about the data science or AI or ML or something like that. Anyway, we can use Kafka to stream the data such as logs and netflow data once and be consumed by the multiple receivers. Kafka takes care of the ordering the messages, acknowledging the receipt to the producers, delivery confirmation to the consumers, and balancing the data between the different recipients. Okay, these are all Kafka is doing that. Why NetFlow we cannot use? Why we cannot use any other like monitoring platforms, something like that? Kafka is also there. We just need to learn about that. It's a new technology which has been came up. We can separate the data into the logical partitions called the topics in a single Kafka cluster. This allows the subscriber to only receive the data they are interested in. So the log receiver will not need to receive the flow data. Entire thing is not going to receive that. There can be many topics can be running on one server with multiple partitions, which are going to come up in the later slides as well. Like, so we can just subscribe to that one topic, so that one topic in the sense a set of network devices which are producing the like the logs or something like that, we can able to receive those things only. Like, so Kafka allows for event-driven architecture, such as triggering events based on the different types of events. For example, a log receiver can page an on-call engineer if it notices the BGP neighbor of the core device going down. So like notifications also can be sent from the Kafka. Kafka allows us to build the centralized pipeline for network data processing instead of having the dispersed teams process bits and pieces of data separately. Centralized pipeline. So this is nothing but streaming of the data. Anyway, we are all having that servers are producing a lot of logs per day. Linux servers are producing, Windows servers are producing, application servers are producing. Network devices are producing each and everything. Like if you just configure that, it will configure it from console to console, something like that. Messages will always be coming out. So we can use the Kafka in this streaming network log flow like that. We are going to see that at least one or two examples in the later slides or something. Let's learn about the Kafka first. Okay. Use cases of Kafka. You can consider the type of companies using the Kafka in their products and services, such as Uber, Netflix, LinkedIn. When we click on the like button on the LinkedIn post, it needs to be appear on the post right away. If you consider how many Netflix movies are streaming on every second, that is high throughput. Of course, the customers of these companies expect all of the operations to take place in real time. It can be applicable for your Facebook and Twitter also, like that. You can even take it for a WhatsApp also. Like, it should be appearing into that persons you are being friends with, like that. So everything has been related. So according to Netflix, Kafka inside a Keystone pipeline, 700 billion messages are ingested on an average day. Netflix is saying that. By their 400 plus Kafka brokers, did they say process 700 billion messages in a day in a real time? You can think of that, how much data must be flowing on that. How do you going to, like monitoring and managing all these things on that? Or let's also consider the Uber's use case, real-time exactly once ad event processing of being a two-way marketplace for Uber Eats. In it, the message need to be fast and reliable, but they also need to ensure the events are processed only once with no overcount or undercount. The events need to be exactly once amongst all the consumers, full stop, like that. So you see, wherever there is a data flow is continuously flowing, like Facebook, Netflix, Amazon Prime, like Uber, Ola too. We are going for that. Swiggy, we are ordering a lot of things. Zomato, we are ordering like that. So everything has been goes as like data streaming, which is coming from a different point of view. Like, so that need to be properly managed, and it has to be delivered to the proper consumers and the producers and the zookeepers. Many other things are coming up on that. They will be seeing that these are all the use cases of the Kafka. Kafka event streaming in a few different points of the network, you can say. We can use Kafka to process the transactions in real time, such as device provisioning from warehouse shipment to fully functional in the data center. We can use Kafka to implement an event-driven architecture. Kafka can be used to track and analyze changes in the network events, such as BGP neighbor relationship or interface flapping. It's not only BGP, always we are picking up the BGP only. There are many other protocols are there. Even if you can just see that in the switch ports flapping or something like that, also we can see that. network topology changes which are happening on the when there is a root switch goes down, or like some of the leaf switches are not operating properly, like that. So many other network events can be triggering. We can use Kafka to capture and analyze IoT and wireless sensor data continuously. This process can be done in the distributed fashion with Kafka servers across the different regions. We can use Kafka to connect, store, make available data produced by the single source to multiple destinations. An example would be store a single set of network SNMP data in the Kafka topic, which multiple monitoring systems can consume. This allows us only to poll the network device once and reduce the CPU and network overhead. So this is what the Kafka is sitting in between the network devices and the SNMP manager. Then it will be picking up all the data and it will be given to the SNMP on this. So we can do a lot of things, but we just need to explore a lot, and research and development need to be done on that, because this has been overall it will be generalized. I can just say that stream of the data can be properly handled with the Kafka. So we just need to understand this, how to tune it up to work with the network devices like that. Prerequisite to go for the Kafka means, like, as an engineer, as a network engineer, what are the things you may require for you to understand that Kafka? That is more important. Linux knowledge is important. Then the people will be asking that, why should I know Linux? Why can't I install the Kafka in Windows platform? Definitely you can install the Kafka on Windows platform. It's possible. But you require a Linux knowledge on that. But if you do it on the Linux, it's good, because anyway, you're going to do all these things with the Python scripting only. Even in Linux, we are just using a lot of Python scripts to run the, to pick up the informations from the network devices. And we are writing, because Python has already been used for the, network automations and other things. We are using that. And the programming skills are required, because you just need to write the scripts, a lot of scripts on this. It's not only just creating the topic or something like that with the commands which Kafka is giving that. So what are the steps like that? In the sense, you just need to create the topic first in Kafka. Then the consumer need to be get started, and the producer need to be get started. There are shell scripts which are available in the Kafka itself. We can run those shell scripts which are available under the bin directory, means a binary executable directory. But those are all not required at all. That may be like, it can produce the data, it can receive the data or something like that under the topic. But what data need to be produced, what data need to be pulled up from the devices, and all these things can come through proper scripting only. That's why I said that we require to have some programming skills in Python. Network devices configs, that you should know at least 3-4 years of your experience in the network configurations, like not only in Cisco. We should be having something on the Juniper or any other devices as well. Like even firewall also we can able to do. Log analysis and troubleshooting. This is the way that we will be starting with the network. As an engineer, we'll be starting with the log analysis and other things. We should know that how to collect the data, syslogs and all. We just need to know that how to log into the syslog server and pulling up all the data and analyzing all these things and troubleshooting it and finding out the exact problems where it has been causing on that. So as Kafka is a small, like a software which can be downloaded from the Apache Kafka website. You can install it in the Ubuntu system. Ubuntu is quite easier. You can install it in any other Linux system also, it's easier. If you come to the Linux, it's nice, because we are going to write a lot of scripting on that. Python scripting has been used very heavily under the Kafka for network operations. I'm saying, I don't know anything about the other people, the software people are doing that, what language they may be writing on that. But Python, I'm just using a lot of Python on this because we've been doing a lot of projects with the Python. So programming skills is required. Python is required, and Linux knowledge is required. What all required? Network device configurations required. You just need to know the commands of Juniper, Cisco, or like this network devices. In the sense, I'm talking about the devices which can be programmed. Programmed in the sense, like it should be of some open source content has to be there. It should be like a SDN devices, like I can just say very frequently. I just like frankly, I can just say SDN device means software defined network level. They should be coming under that kind of a devices where some open source material also can be utilized to pull up the data from that devices. Means like all the Cisco, which is only the Cisco commands are going to run on that, which is not possible. We require to activate that sandbox. We just need to activate the APIs. Application programming interfaces and Sandbox need to be activated. HTTP port need to be activated on the devices. So the devices which are, I can say, for example, Cisco Nexus can be done with all. like Kafka through managing the Kafka like that. We can do it. Other devices, we just need to find out that we need to go through the documentations of the Cisco and Juniper and other things, which can be where we can go and activate the APIs, Sandbox, HTTP ports and other things, so that we can able to pull the data from the outside, a third party software like a Kafka, managing software like Kafka. So these are all required. So be required to know at least some of the programming skills, and log analysis and troubleshooting is required. So prerequisites, I'm telling that. So any person who has been going to the kind of network automation or something, he requires all these things. Definitely I can just say. Okay, let's go to the next. What are the disadvantages of Kafka? That also we just need to know that. It's not only the advantages. Kafka clusters can be complex and hard to set up. Definitely. I took a lot of, about 10 days on that. You can think of it. 10 days it took for me to set it up properly, to run certain applications, talking to the Nexus box on that. Managing a Kafka can have high learning curve. Definitely. You require to learn a lot of new things. By design, Kafka does not contain some standard features like storage solutions are having it, and it doesn't have the message validation for the producers by default. Means validation cannot be done. It is just going to produce that, that's it. We are in a position to go and find out all these things, whether they are right or wrong someday. Kafka has a fast evolving ecosystem that sometimes makes keeping systems up to date is a challenge. Yeah, definitely. There may be some other bugs and all like that. The commands getting changed on this. APIs need to be talked to that properly. Cisco Nexus need to be, like configured properly on this. So these are all I can just say like this is, don't take it as like a disadvantage. It's like a bottlenecks. You just need to solve all these things. Complex and hard to set it up. Maybe like one time if you just spend some time to set it up the Kafka, then it is going to work out. Definitely. For last 15 days, it has been perfectly working in my own laptop. I didn't install it in anywhere else. But initially it was a very huge hiccups happened. I should admit that. And high learning curve, because you're learning a new technology, definitely it's a high learning curve. And these are all like, Kafka by design, there is some issues are there. We don't need to go through that because we are not going to get into the deeper of Kafka, what is it actually doing and all like that. We look for kind of network log as a service, network pipelines, network data feed, something that we will be using that mostly like around 30-40% of the Kafka we are using on this. And up to date is a challenge that we can go for the higher machines, higher software versions and other things we can do it. Next, Kafka concepts. Concepts are maybe like boring, but we just need to understand that how the Kafka is working on that. So then you will be able to understand whether the Kafka is producing the proper, proper topics are running. The topics are running properly. The producers are trying to get the information from there, and the consumers are getting that like that. So we need to troubleshoot that. Means we just need to understand that what is actually happening, and for that we require to understand the Kafka concepts. Was developed with a newer data pipeline in mind, which treats the data as a continuous stream. As a result, there are several parts and concepts related to the Kafka data streaming system. So this is a very important one, like a Zookeeper, brokers, producers, and the consumers. These are all the things which we will be mostly talking about this thing in the, whenever we are talking about the Kafka. In a distributed system, we need to build, manage, scaling, and maintain the group of distributed servers. Kafka system uses the Zookeepers, another open source project, to manage the servers within the cluster. The Kafka servers containing the data themselves, topics and events, are called as brokers. The system allows the producing the data and subscribing the messages continuously, write and read. Hence, they are appropriately named as the producers and consumers. The producers and the consumers generally take the form of SDK or API sitting in the servers communicating to the Kafka cluster. Here, we will use the Python SDK and shell scripts as producers and customer. That's what I was telling, that we just need to know the Python script for that. So if you would like to pull up the data continuously from that, and you need to write a lot of scripting on this Python, you just need to learn the Python as well. Okay, anyway, that is also another requirement. I already told you that. Okay, next, it's continuing. The system needs to be storing the events for some time. This step is generally in the form of topics consisting of the partitions. Within the partitions, each event is labeled as a number called offset. This is identification of the message which we use to track where the consumers have been consumed. The systems need to process the streams of events as they occur and react to any unforeseen circumstances, such as backing up partitions and reallocating them when a broker is unexpectedly down. The components responsible for those processes are zookeepers and the brokers. So these are all the things we need to understand: the zookeeper, broker, producer, consumers, topics. Okay, these are all the components. You can just take it up. But we have the script which has been run in the Kafka bin directory itself. Once you install that Kafka in your Ubuntu, you'll have having the binary executable directory bin directory. The bin directory has got all the scripts already been there. Shell script is there. Like consumer script, producer script, topic script, everything has been there. Okay. But we need to write what information we are going to pick it up from the particular devices which we need to do it. That for that we require to write the script on the either in Python. I tried in Python. We can try something on the like YAML or something like that. I don't know. We can try that. Okay. Next, this is the Kafka overview. This is the producer. This is take it as like this is a cluster, and this is the cluster. In the cluster, there are many topics. Are there 1, 2, 3 topics? Are there 3 topics in the sense 3 different kind of network information we are going to get it from the different network, different subnets you can take. Like that. These are all the brokers it's called. And these are all the producers which are producing the according to the topic, what data they are looking for. And at last, the consumers will be getting the information from it. So this you can take it as like a Kafka cluster. This Kafka cluster is running with the Zookeepers as a brokers, and the producers which are producing the network streaming of log or anything like that, which is being getting processed under the partitions of each and every topic on that. Like you can take it as like a 3 different companies which are we are doing some kind of a network maintenance and monitoring or something like that. We took 3 contracts from the 3 different companies like Cognizant, Accenture, and some other company. So we pick it up from the 3 different topics like that. We can give it to the consumers which they require only. Means only the NOC team of the Cognizant require only the Cognizant only like that. So that team will be getting that. So here the like Accenture only will be getting on this. This is only the Capgemini will be only getting on this. Like so, this is like a very simplest form. It's just saying that it is not so easy to set it up like this. So, 1 or 2 words or something, 1 or 2 minutes or something, it is not going to work out in that way. Definitely, I'm telling that I took so much of a time to understand this particular concepts, and I installed it, and it is working perfectly. But once it has been installed properly, then there is no, like worrying about that, whether it's going to work, it's going to produce that, it's going to consuming, like everything will be perfectly running. So this, you can take it as like 3 different companies in the Kafka clusters. We have created 3 different topics on that. On the 3 different topics, the message is going to flow through the producers, and the consumers are going to get all the information from this particular topic. Very simple. I explained it simple, I guess so. Because if you understand, it's nice. Anyway, let's go to the next. Zookeepers. Well, we will be seeing one by one. What is Zookeeper? What is broker? What is consumer? What is producer? What is topic? Like what is offset? Everything will be seeing that. Apache Zookeepers is itself a popular open source project. We already seen it. Primary function to provide the reliable distributed coordination between the application. That's what. It's like what is it? It's sitting in the cluster itself, and it is controlling the producer as well as the consumer. There can be multiple Zookeepers in a Kafka cluster, and the recommended number is 3 to 5 Zookeepers in a production Kafka cluster. The number should be an odd number to keep the quorum of the leader selection. However, the number should be kept as low as possible to minimize the overhead. There you can calculate when you go for a designing or something like that, how much you would like to run it in one server or something like that. Then it is important to realize Zookeeper is a separate service with its configuration file and runtime service for our purpose. It is also important to note that Kafka brokers require Zookeepers to function prior to put them into the service. This is like order of execution. The Zookeeper keeps the state of the cluster, that's broker, topic, users, and more. This is a Zookeeper, broker. Kafka brokers are the workhorse of the Kafka cluster. Generally, single Kafka server is 1 broker. There has to be at least 1 broker per Kafka cluster. This is where the confusion starts. Let me read that again. The Kafka brokers are the workhorse of the Kafka cluster. Okay. Generally, a single Kafka server is one broker. Okay. So there has to be at least one broker per Kafka cluster. Anyway, it's clear, no? Each broker has a broker ID that uses to register with a Zookeeper. Like that. Kafka broker is where the producers and clients will communicate with the cluster when they need to write or read messages from the topic. Yeah. And the brokers receives the messages from the producers, assigns offsets to them, the numbering, ID like that, and commits them to the storage on a disk. At this point, the broker would send a confirmation to the producer to the signal the success of the message commit. The broker also services consumers. They would respond to the message pull request from the consumer. Exactly. This is going to be the heart of the things. And it is going to get all the information from the producers, and it is storing it, and it is giving it to the consumers. When the consumers require, they will make a pull request. Depending on the hardware, one broker can handle thousands of requests. We will have at least one broker per cluster, but having more than one broker allows redundancy and additional performance gain. Kafka brokers are designed to be operated as a part of the cluster. Within a cluster, one broker will be elected as a controller. The controller is responsible for assigning partitions to the brokers and monitoring other broker failures. These are all when we go for a Kafka related problems, when you try troubleshooting it, you just need to go through this chapter. Okay. Topics. A topic is simply a category or a name of field. We can configure our cluster to allow automatic topic creation when the sender feeds our cluster to a topic that does not exist. A good analogy for a topic would be file folder on your computer. Just like we group related files to into folder, we group related message to the topic. Simple. That is called topic. Topic is nothing but that we are going to receive certain devices information so that those devices can be grouped together as a one topic. Like Capgemini is one topic, Accenture is another topic, Cognizant is another topic, like that. I'm just saying, but maybe in a within the company itself, we will be having a lot of consumers will be there. So accordingly, we will be grouping it. Partitions. Kafka's topics are divided into several partitions. The multiple partitions per topic allow the data to be split across the multiple brokers. Having the message across numerous brokers allow the parallel processing. When we want to increase the read and write performance, one of the options is to increase the number of brokers and partitions for our topics. We are going to see some other picture like that, how the partition topic and other things are there in this. You see that. Broker 1, broker 2, broker 3. This is the topic A, partition 1 replica. Right. And this is a broker 2, topic A, partition 0. This is broker 3, partition 1 and partition A, replica, something like that. It's been there. So this, we will be getting the information from here. We can see a topic A divided into 2 partitions. Each partition has a replication factor of 2 for redundancy. The placement of the partitions are intelligently managed with the Zookeeper between 3 brokers. There are 3 brokers there in this. So as per the design considerations, you don't go beyond the 3 years on the other. That's what they say. Okay. Next, message offsets. This is the ID which has been given for the message received. Each of the messages in the partition is assigned with a number called offset. The concept of offset is essential. This offset number gives a point of reference in the messages. It allows the Zookeeper to know when a producer sends a new message to an existing topic, where it should be appended with a new message. The offset also allows the Kafka cluster to keep track of where the consumer has processed the messages. These are all the ID numbers which are given for them. Next, last one is the producer and consumers. The producer and consumers are applications writing to and reading from the Kafka cluster. When the producer sends a message to the topic, it is published to the topic partition's leader. The leader will commit the message, it's a log, and increment the record of it. Kafka will only send the message to the consumer once a message has been committed. Therefore, we can configure our producer to wait for the message commit confirmation. If the confirmation is not received, the producer can resend the message to ensure the integrity of the message delivery. This much is happening. Consumers pull messages from the topic specified to Kafka. To be precise, the messages are from the broker, which contains the partitions of the messages. In practice, Consumers typically form consumer groups. A consumer group is a group of consumers who share the same group ID. They allow multiple consumers to share the load of process messages. This is again further down load balancing. Consumer groups are a great way to parallelize the operations. Multiple consumers can process a message simultaneously. As mentioned, the best part is that load balancing of messages is automatically taken care by Kafka. This is the producers and consumers. So what all things which we seen? We seen about the Zookeeper. That is nothing but within the Kafka cluster it is there. It is pointing like CPU. You can just say central processing unit, like between the producers and the consumers. Brokers, workhorse of the Kafka cluster is having a one broker or other. Then topics are the one which is going to be a category. You can just say that. So we can understand automatic topic creation. Sender feeds of the cluster topic does not exist. So the topics are the one which identifies that which is going to be the which kind of a data stream or something. You can see. Partitions are the one which is going to store the messages as well. It's like a hard disk partitions, you can say. The last one, so now the last one, message offsets are the one which are by the, like the broker or somebody who's receiving that. Zookeeper is receiving the message in the sense it is going to assign some ID to that. And last, the producers and consumers. Producers are going to produce the data, and the consumers are going to pull the data from the, like Zookeeper. This much. This is how the Kafka is being operating. And we can come to know about some of the Kafka tools as well. Kafka Connect, stream processing, management consoles. This we can see later also. Anyway, Kafka Connect is a built-in framework for the connectors. These connectors allows us to pre-build the code for different sources and the different destinations called the sinks. For example, connector sources for relational databases and destination sinks like Elasticsearch, Amazon S3, and Azure Blob Storage. Stream processing. If we treat the data as a continuous stream, it will make sense to multiple steps in a streaming process. Tool chain in the Kafka stream is a vast enough to have dedicated projects and libraries. So this is like such as Kafka Stream, Storm, Sensor, Kafka Storm, and other things. Management consoles. We have Kafka Manager, Kafka, Cruise Control, and other things. So this is about the Kafka tools, which we will be using it like if you like to have it on the GUI kind of a thing. So we can go with this. Kafka in the public cloud. As I told you, like Kafka can be installed in the public clouds as well, means in Amazon, Microsoft Azure, as well as on the Google Cloud. AWS managed Kafka service. They're saying AWS managed streaming for Apache Kafka, MSK. The overall promise of the service is pretty simple and straightforward. We can use the AWS CLI or portal to create the cluster, specify the number of type of EC2 instance our brokers and Zookeepers will be living in, and the Amazon MSK will take care of the rest. After the cluster is provisioned, we will receive connection strings. The connection string is how we can connect to the Kafka cluster. Since we do not manage the Zookeeper or Kafka brokers directly, significantly reducing the management overhead, we also have cluster-wide storage scaling. So this is how the stream flow which has been happening on this slide. So this is the first step, second step, third step, fourth step, and fifth step. How do we use Amazon, like MSK? Amazon MSK is easy to run Apache Kafka on that. This is the first step. Create your own Apache cluster, and easy to build and configure the producers and consumers. Connect producers and consumers to the Amazon MSK. Run the streaming applications like this. So more operated, more automated when you go to the Amazon or any other, like public cloud or something. Anyway, let's see the benefits of Amazon MSK. Apache Kafka compatible. This is a fully open source version of Kafka. Application, tooling, plugins developed by a Kafka ecosystem are supported and compatible in Amazon. Fully managed, as we have stressed, we do not need to worry about the provisioning, configuration, and maintenance of the cluster. Reduced operational overhead would allow us to focus on our application features and data management rather than, like building up the Kafka cluster and making the things and breaking our head and other things. It's not required. Highly available. AWS maintains highly available regions and zones around the globe. That is, everyone knows that. Okay, this is about how the Kafka can be integrated in Amazon. Next is Azure Event Hub. Azure Event Hub, Microsoft Azure Event Hub is a data streaming platform. It is very similar to the Kafka in terms of having publishers and subscribers. Azure Event Hub is a unique in terms of support for a compatibility for Kafka, Apache Kafka. However, Event Hub uses a different terminology to describe its Kafka equivalent cousins. Kafka cluster is nothing but Event Hub namespace. Kafka topic, it's Event Hub. Kafka partition, Event Hub partition. Kafka consumer group, Event Hub consumer group. Kafka offset, Event Hub offset. Everything they named as like event. There are also some differences between the two, such as asynchronous messaging options in Azure. The last one is a Google. Google Cloud PubSub, public and subordinate, something like that you can take, provides the familiar technology for us in terms of public publishers and subscribers. Sorry, subscribers it is. Publishers can send a message to the PubSub service, where the subscribers can receive events from the service. If you already use Google Cloud big data services like Dataflow, BigQuery, and Bigtable, PubSub service would complement them by allowing the multiple clients to subscribe to the same event simultaneously. PubSub service differs from Kafka in terms of parallel processing. It offers per message parallelism instead of Kafka's partition-based parallel processing. This means we do not need to improve the number of partitions in order to increase the performance. So there are some kind of fine tunings are available on this. So these are all the three public cloud operations are there. One is an AWS managed one. Another one is Azure Event Hub. The last one is a Google Cloud PubSub, like this. So now we will come to our topic like network operations with Kafka. How we are going to manage our network devices by using the Kafka which is installed in any one of the server, and what all the things are required for that, how we are going to operate with that. Daily day-to-day operations, log services, network data feeds, like SNMP devices, polling and other things. How it is going to work out on this. Network operations. We are particularly interested in how Kafka can be integrated into the network management. There are several ways we can incorporate Kafka into our workflow. For instance, we can use the Kafka to manage and enhance data such as logs, or we can use Kafka as an intermediary component to smooth out the data stream. Some of the network use cases: Cisco engineering Kafka for secure autonomous operation, Cisco's real-time ingestion architecture with the Kafka Android, Nano 65, monitor the BGP using the open source or open BMP and Apache Kafka. These are all the very high-fun things. Benefits of Kafka in the network. When we started using the Kafka as an automation tool for log collection and analysis and other things, what are the benefits we are going to get? Scalability and separation of the concepts. In simple tasks, it's most always an overkill. But when we look closer, there are many benefits of using the Kafka. We can have multiple producers querying the network devices. Each producer can handle the micro segment of network or device, such as spine only, leaf only row. We can also separate the task by know-how. For example, we can have another producer handling all iOS devices or Juniper devices, depending on engineer expertise. Like that, we can do that. We do not need to use the same language for writing the producers. Kafka provides many different SDKs for different languages. If our team member decides to use Go or C++, C# or something, they are free to do so. If there are multiple teams required to use the same network output, multiple consumer groups can be used. Kafka cluster will be in charge of the ordering and delivery. So this is how we can use it. Like, so we can, the producers are going to pull up all the data from the, the network devices on this, and we can separate it, and we can give it to the multiple consumer groups as well. And we can even write the SDKs by using any other language, whichever we are very much comfortable with. Like, I'm going with a Python in this case. Okay, the next one, benefits of Kafka is continuing. By having the Kafka handle the messages, we do not need to put more overhead on the network devices when more group needs the same information. We query the network device once, regardless of how many times the message is being consumed by different groups. Like, just one hit will bring up all the data to the Kafka cluster. Later, Kafka cluster will decide to give it to the multiple consumer group by replicating. That is the wonder. Okay, the data has been retained and persisted by the Kafka cluster for a period of time. We do not have to worry about the data collectors or consumers going offline for a period of time. Means Kafka will manage it. Another benefit of using the Kafka is the fact that we can start enrich the data by adding the more information and transforming the data. With Kafka, we can do these three things on Cisco Nexus. That's what I was looking for a Nexus only, because Nexus supports an API, Sandbox, like port, like HTTP port can be, HTTPS port can be activated. And I can go and do some kind of programming like that, programming stuff on this. I can log into the programming console inside the Nexus, and I can do. And we can get the outputs as well as this continuous stream also we can get from Cisco Nexus. That is a network data feed, network data pipeline, network log as a service. These three things which we can get it from any network device, not only from Cisco. Maybe like if you know something on a Juniper side, if you know something on some of the firewalls like Palo Alto, Checkpoint, or something like that, if they're supporting that, we can pull up that, because all the SOC engineers require that all the like events which are happening on the particular firewall need to be properly analyzed, and it's going to be a continuous stream as well, like definitely. So we can use them also in the firewall industry also. So network data feed, we will begin by using the Linux API query to the network device information and feed them into the Kafka topic. To use the Linux API, we will need to turn on the feature as well as perform some related configuration tasks. Feature NX API, feature NX API, NX API HTTP port, NX API Sandbox. These three things need to be activated. I have some Nexus 7K with me, means I installed it in the GNS3. We'll be showing you later. So I can configure these things with that. If you have a NX, like Nexus 9K will eat a lot of memory from your laptop. So I installed the 7K for like a demonstration, and to understand the topics and other things. 7K is enough. It doesn't take more than 3 GB or something from your laptop. Okay, we will create a topic, then we will use the Python script to query the network devices with a structured data back containing what would typically we'll see the show version output. We will start by slowly. Show version will pick it up. Show inventory will pick it up. Show IP interface brief will pick it up. Show modules will pick it up. Like all the show commands, we will just query and get that. Query is nothing but the producing. Producer will do the query. Consumer will take up the information from that. Like that. So now you can understand the Kafka, how does it working. In between the Zookeeper and the brokers are sitting in that. Now it's very clear. And on the consumer end, we should see the output for the device as well as the software version. Okay, this is one of the service like a data feed. The next one is, sorry, it went off. Okay, network data pipeline. In the network data pipeline, we will take the messages from the topic, transform them, then push them into the another topic. Means picking up from thing, taking it, transforming it, pushing it to the another topic. Producer for the topic 1 and the consumer topic 1. This is the first step. Consumer topic is the second step. Enhance the topic or message is the third step. Produce it to the topic on the fourth step. Means like we can pick up some kind of inventory. Yeah, that's what. We will take a show inventory output from the device. We will match the device with an external CSV file that contains the address of the device. Means like in which rack, which data center, which city, who is managing the SNMP, all SNMP information we'll put on that. So we will ask the topic to pick up that external CSV file and combine both the outputs, inventory output as well as the CSV, where it has been located on that, and it will be producing it to the new topic of this. We will produce the new record with the additional information. We will push the new record to the new topic. Like so, it's a little bit like complicated, but it is easy to execute once you started producing certain topics on that and collecting all the informations. It's very easy for you to go with the mingling the topics one by one. Like the last one is network log as a service. We will treat the network log as a service. There is an overall flow. Store the network log as a log file. We will use Kafka to read from the log file whenever new contents are added. We will push the data into the topic to the Elasticsearch container. We will use the Kibana to view all stream flow on a browser. So this is the most critical and very hardest part to configure it like to work as like, because network log is a very heavy thing. Because a network log in the sense, it's not from one device or two devices. It's going to be coming out from the 5,000, 6,000 devices. The logs are going to come out. Flow. We can even, configure it. Like we require only the critical messages, or we require only the emergency messages, something like that. We just need to configure that in the devices. Not pulling all the message like 0 to 7. We are not picking up. We are picking up only the 4, 5, 6 or something like that. We'll just pick up the messages only. Only notification things we can alarms we can like that. When it is coming from the 5,000 devices, a huge volume of data. How you are going to handle it? With that we will be requiring an Elasticsearch, Kibana, and complete proper setup of the Kafka, and everything will be doing all this. So these three things, which we can do it from on the network point of view by using the Kafka. Network data feed is nothing but like just simply picking up the show informations, show command, show IP route, or like a show IP BGP neighbor, or show IP AGRP neighbor, something like that. Topological informations, BGP table informations, version information, hardware software informations, and how many people are logging to the device or something like that informations, TACAX informations, like a lot of other informations which you can ask me, like, and tell me, like, we can directly go and log into the device and run the command. No, okay. 1 or 2 device means you can run the command. If you would like to pick it up from the 5,000 devices, volume is the problem here. For that, we are using the automation on this. So for that, we require to activate certain things on the network devices. There is nothing but a API and Sandbox and HTTP port. Once you've done it, we will be able to run the topic. The topic, by subscribing to the topic, the producer will pull the informations and produce it to the Kafka cluster. The Kafka cluster broker and the Zookeepers will be processing the data properly and then give it to the consumer who is being subscribed to that. That's it. So this is a network data feed. First one, network data pipeline. This is combining the two informations from one topic to the another topic and combining the both information and producing it to the consumers. This is a little bit complicated. The third one is a heavily complicated. Elasticsearch and Kibana and other things, we need to configure that completely. Then only we will be able to pick up all the information as when they are happening. Means like a live stream, we can see that. So this is about the Kafka on the network. I guess I have given you proper information about the Kafka on this one. I've given you some introductions, taken all the like components which are there inside on this, and how do we use it on the network side on this. So this is about the Kafka on this one. So this is my contact information. You can call me or WhatsApp me, or you can email it to me. And very importantly, subscribe to my channel, because I'm going to push so many topics on the Kafka, which I have done a lot of practicals on this. And I'm going to put all the labs on the YouTube itself, because it's a very new topic. And I searched, frankly, I'm telling that I searched many, like in YouTube itself, like if there is any videos of that to do the Kafka implementations on the network, I don't find anything, zero, nil. So I thought, why shouldn't I make it up like, because people are moving towards automations very heavily. I have been doing a lot of projects on the Ansible. Ansible is like a child's play nowadays. And the Python, we are doing that for many other companies as well. So why don't we use the Kafka also? Because Kafka, it's like a centralized system which has been installed, and I can even integrate the network devices as well for that. They are using it for some different purposes, like data science and other thing. They are using it. I can ask them to, like creating a topic for network devices so that can be managed easily like that. So it's going to be some other things which I'm going to show you to you on this, and a small, the topic which I would like to show you on my Ubuntu server. I installed it on the Ubuntu server. I logged in here. This is just a Ubuntu server. You can just see that sudo hostname CTL. Okay. The name which I give it is like an Ansible, because I am running it is like an Ansible server on this one. And this is VMware. It's Ubuntu 20, which I upgraded. Actually, it was an 18 only. Okay, it's normal Ubuntu. You can just install it. Very simple installation of the Ubuntu itself. Okay, in the Ubuntu, we don't require anything on a heavy things or something. We require a Java. That the prerequisites are there. You just need to install the Java Open JDK. Once you install it, then you can download the Apache Kafka from the sites. Like you can go to the Apache Kafka. Let me show you that. It's a free software. Apache Kafka. It's a, you can go to that site and you can get that information. It's taking so much time. What is Kafka? It's here. Microservices. So many companies have started using that. Confluent Developer, microservices, and what is Apache Kafka? Kafka Streams and SQL DB. Very slow, I guess. Net is okay. What is Apache Kafka? Okay. Web, customer apps, microservices, monitoring, analytics. It's using all these platforms as well. Anything source, CC, Twitter, Oracle, data warehouse. This is all talking about so many, like thousands of companies are built in Kafka. Netflix, you see that? Very important. Airbnb, Microsoft, Netflix, New York Times, Intuit, LinkedIn, Goldman Sachs. How Kafka can help you? That's what. Publish and subscribe, store, and process. It's like this. Kafka definitive guide. I can get these books and all. If you like to go for downloading, like get started for free, something like it's a Confluent, it is going to that site. Maybe like get started for free. You can look for cloud and software. We can download that. I guess it's gone to some other Apache Kafka download. Let me go. Kafka download. Internet connection. Okay. Download Apache Kafka. That's here. Connection is not good. Yes, maybe. It's a 3.20 is the latest version, which I installed is, I guess, 2.12 and 2.13 something is there. You can download it from here. The data also has been given like May 13, 2022. So we can have this, like this is the Kafka, and what all things we are going to run on this one, like we just need to create the topic. Okay. So the first one, you just see that create the topic first. Kafka console consumer.sh, bootstrap server, and the topic is going to be the demo topic. Then you start the consumer, like consumer.sh. This is a shell script which has been built on the bin directory itself. We will be finding all the script over there, shell script. We just need to run it like a command. We need to run the script on this. And bootstrap server, we need to give 127.0.0.1, that is nothing but a local host, which is running on 9092 port. And the topic, subscribe to the topic is a demo topic. Where we given the topic name, it should be coming up as it is. Then run the producer. This is going to pull up all the information on this. Console consumer, console producer. First, we need to create the topic. Second, we need to run the consumer. Third, we need to run the producer. From the producer, whatever the data we are going to feed it on this, consumer will be getting their information on that. Very simple. I'll show you that. And let me create the topic first. I'll just copy paste. I don't want to make any mistakes here. So I'm creating that Kafka console consumer sh. Before that, what do we need to do? We need to understand whether the Zookeeper and the Kafka is running or not. Systemctl status Zookeeper. Would like to spelling mistake. Status Zookeeper. It is active and it is running. Okay, it's running. Then I would like to check Kafka is running on it. KAFK. Kafka is also active and running. These two services need to run properly so that we can able to run the topic, producer, consumers, and everything. We can do that. And let me run this. Okay. Copy this, and I'm creating a topic here. It will say the demo topic has been created. Error while fetching the data correlation. Data not available. Where is it so? And then let me log into this Ansible. That is a Change the menu topic. One second. Let me check this. I have to create a topic like this. I given a wrong command. Let me do that. This is how the creating the topic. Create the topic. It is called as a test topic. So let me make it as like a test topic. That is a consumer actually, consumer. Let me create this topic, create the topic as a test topic. On the port number 9092 on localhost. Replication factor is 1, partitions are 3. Let me create the test topic first. Now the topic will get created. Now it is saying that created the test topic. Now the topic is created. I just need to run the consumer now. This is the consumer. Let me change the name of this topic. What is the topic we can test? The name should be the same one. Like that. This is going to be the consumer. He will be receiving the messages from here. Let me go to that and I will be running that. Let me go to this directory. Here I'll see all the, like SH means is a shell script file. Shell file. You see the topics is a server start, server stop, like cluster, consumer, producer, consumer groups. Every other script has been there. So what we need to do, we need to create the producer. Here let me change it as like a test. We copy that, run the producer. This will be giving me the prompt on this. Whatever I type on this one, the consumer will be receiving that information. So now I got the prompt here. Hello, I am testing the Kafka producer. The same I will be getting it. Hello, I am testing the Kafka producer. Here you just see. You seeing that? Hello, I am getting the Kafka producer. Thank you. You got the message. Now I'll just see that same information here. Thank you. You got the message. So like this is like within the server only I'm running on that. Don't get confused. This is within the same server. There's a second login I made it on this. This is the first, this is the same server which I made it on the second login as well. Second SSH session, terminal session I opened. And this is acting like a producer and this is acting like a consumer. And the topic which has been already created on the first, and the Zookeeper and Kafka services are running already. What actually in the real scenario will be, this will be the server which will be producing this one, and the consumers will be in somewhere else. Like they will be, like pulling up all the, through the network, they will be pulling up all these things. So the producer will be having the script which is required for to pull up from the devices, network devices on that. Either it is a show version, show inventory, or show IP interface brief, or any other commands like that, like a routing table or a topological table or OSPF table or something. So we will be getting all these information through the producer, and the Kafka, the bootstrap server, which is there inside the Zookeeper and broker will be processing that output, and whoever has been consumers who are subscribed to the particular topic will be receiving the message like this. So if I close this one, I'll be seeing the 2 messages, processed 2 messages. I can even close it like this. This is just a testing only. Okay. This is not an actual thing because I'm producing in the same server, receiving in the same server. This is not the case like that. I just need to reduce. I just need to get it on from the different systems as well. So this is a very simple practice which I've shown you, like how Kafka producers and consumers are running, and how the Zookeeper service is running, as well as the Kafka service is running on this. I hope this must have given you the proper information about the Kafka, right? And if you would like to have some more details about this, you can contact me on my WhatsApp. That's a number has been given on that, and you can email it to me. And you can subscribe to my channel. As usual, I always ask you, like, the last line, youtube.com/c/ramnathkesav. And please introduce my channel to your friends and colleagues and relatives and other people. So it's a completely tech channel. It's a free. You can even download these things. And thanks for joining today. Okay. And put me on the comments on this. I'll be making the second video on the Kafka by giving the Nexus, talking to the Kafka as well. Maybe like next week I'll be doing that video. If you'd like to have anything more, just contact me on this one. Anyway, thank you very much for joining. Thank you very much. Bye.